This is the most millennial lesson on compressors. So if you don't know what they are or how they work and you were born before 1996, watch this. Okay, remember in math class, intro to functions with the input and output tables. They looked like this. You have the little funnel that says input, and there'd be a gear because it's a machine, right? And a little output spout and a little friggin' steam whistle. And the function would be y equals 2x. So you'd be like, oh, well, then if I put 1 here, then, 1 times 2 means y is 2. But if I put 2 here, then 2 times 2 equals 4, and, whatever, right? Yeah, I can still multiply. Stay with me, I promise this ties in. Because this is essentially what a compressor is. So let me show you on an audio wave. So here's an audio wave, right? The blue is the actual sound, and then on the side, these would be measured by decibels normally, but we're just going to use regular numbers to make this easy to understand. Going from 0 to 10 in either direction. So 0 is complete silence, and then like a normal wave, the outsides are the loudest. And if we look at these waveforms, we can actually see like values on them, right? So this is like a loudness, we'll say of 3, because it's between 2 and 4. And this is also 3, and like maybe up here's 9, and this one's like 10, and this guy here is 6, right? You get the idea, right? We're just saying, oh, that's how loud these different peaks are. We're essentially sampling each of these peaks. And so we're going to say this blue line and its values, that's X. So let's fill that out. So we have 3. We have 3 again. We have 2. We have 3. Sorry, can't math. We have 9. And we have, we'll say 11 down there. I'll cut this. Yeah, I crossed my 9s, what of it? And this list would go on and on for all the other points. So now let's say y equals x divided by 2. Which would mean that this is 1.5, this is 1.5, this is 1, 1.5, 4.5, 5.5. And so what would happen over here, right, is now this peak goes there, and this peak goes there, and this peak is there, and we have another 1.5, this is a 2, something like that, I forget. It's like cut in half, essentially. 2, 4.5, so on and so forth. So if I connect these dots, this is now the waveform that we get, where everything is cut in half. So now the difference between the quietest and the loudest part is not nearly as extreme. And so this part here, we call this the ratio when it comes to compressors. And in this example, we did a 2-to-1 ratio. But there's another term you may have heard of, and that term's called threshold. So what we're going to do in this is we're going to say, you know what? Anything below 4 in this example, don't touch it. So let's go back over here. So 3 is less than 4, so 3 stays as 3. Same with 2. Same with 3 again. But 9 is greater than 4, so we're going to apply this ratio to it, and same with 11. So how would that look like over here? So this would be the same as the blue, same as the blue. Oh, but since this is above, we're going to follow the red line now. And this line here, could also apply here, is above, is greater than 4, so that would apply. And this 6 is above, so this would apply here. This little guy not so much, right, because that blue doesn't. The blue here applies, so we're going to follow the red. This is essentially how this works, so I'll speed this up. All right, pardon the crappy drawing, because drawing while looking at a phone with an expo marker is kind of difficult to do. But you get the idea, right? If the blue is in between these lines, it doesn't pass them, we follow it. If it goes above it, then we follow the red line because it's exceeded the threshold. So let's mark this. Boom. Threshold. 2 H's, who knows? Threshold. Which leaves one more piece, and that is the knee. So let's zoom into a part to where it crosses the threshold. So I'm going to redraw this so it's less sloppy. So if I approach this threshold and then kick in the ratio, the compression right here very abruptly, you're gonna kind of have like here's the original waveform, and then it's gonna compress over like that. And so you have this like very distinct hard angle, right? This is a hard knee. This is literally what it's called, hard knee. If, however, you caress it, you're like, and it's more like, here's your original waveform, and then you like slowly curve into the new one. This here is a soft knee. So it's really just how extreme the compressor kicks in when it approaches that threshold. So let's mark this. Boom. Knee. So to recap, threshold says once you pass this threshold, kick in the ratio. And the ratio says however loud the X is, the original waveform is, take whatever the ratio is, the function, right? It could be 2, 4, 6, 1 point, whatever you want it to be, and then create a new output. So, and the effect of that is you begin to shorten the distance between your quietest parts and your loudest parts. And then the knee is, well, how extreme, how much of an angle are we smoothing out the difference between the original waveform and the compressed waveform, or signal rather, when it crosses that threshold. So why do you want to use compressors? A common example is if you're mixing a song and in the quietest parts, you got to raise your volume, and then the loudest parts, you got to dial your volume back. It means that these two, like the difference between the quietest and the loudest is too extreme. And so you want to dial those back so you don't have to touch the fader manually. It could also be used to bring out certain timbres and harmonics within an instrument. So let's say this is a frequency spectrum. So this is, 20 to 20,000. And this is your loudness, right? You may really like the sound of this area, but it gets lost in your low end and maybe like your mids and your high end, and you want to bring out this low mid end. When you compress, this is a bad line by the way, but you get the idea, you're minimizing the distance between these 2 points. So when that happens, you could even turn the volume up on it, which makes everything louder, but this doesn't get lost, right? If you turn up the volume on this and this would just be way overpowering. Now you're making these closer, and then you can balance this more evenly. So there you have it, compressors for millennials. If that helped, please like and subscribe. And also, I have a free music theory course and production course I'm making on YouTube, over 50 lessons long, totally free. So check out my YouTube at Alexander Music. That's Alexander with an I because I'm weird like that. See ya.